Hi, my name is Jags Ramnaran. I am from SnappyData. SnappyData is a startup that's focused on building a next generation unified analytics platform based on Apache Spark. The purpose of this screencast is to provide you folks a quick overview of the project we recently announced, a multi-cloud Spark application service on the Pivotal Container Service or PKS. This project is really a joint collaborative, it is a joint collaboration between engineers from SnappyData and Pivotal. The genesis behind the project was to provide a streamlined way of deploying, scaling, and managing your Spark applications. In a way, it was about enabling teams to deploy and run Spark apps batch as well as interactive apps concurrently, use notebook environments, provide a way to unify logging across many applications so that you can do historical analysis of your logs, showcase multi-tenancy, and show you how you can use the multitude of storage options that are available in PKS, like for instance using vSAN with vSphere, using the Google Cloud Store, S3 or whatnot, right? So essentially, in a way, we wanted to show you the power of PKS to deploy and run essentially composite Spark apps. So what do I mean by composite Spark apps, right? So for those of you who are familiar with Spark and you might have noticed that in Spark 2.3, Spark recently added support for K8s, Kubernetes as a scheduler backend. But that really provides very minimal capabilities, right? You cannot auto scale, use Python, or it's kind of difficult to essentially run interactive workloads. So in this project, we go well beyond that, right? We support not only Spark batch jobs, but we also support things like auto scaling. You can essentially start up, Zeppelin as a notebook environment server, and you can also use Jupyter, right? Finally, we provide a way to manage all your logs in a central location, so you can come back and do deeper analysis. The other important point is that rather than having to essentially work with Kubernetes objects and YAMLs for all sorts of resources directly, we use Helm charts to simplify how you describe your composite Spark application cluster to PKS, right? So given that, Spark apps can involve many components like Kafka, streaming, notebooks, storage, whatnot. I think Helm makes it really simple, right, to deploy and manage these applications. Helm, for those of you who don't know, is actually a package manager for Kubernetes. And the thing I really like about Helm is that it really hides a lot of these Kubernetes constructs like deployments, daemon sets, or whatnot. So while I don't have time to really get into PKS details, but for anyone listening who is familiar with Kubernetes, you may be wondering like, hey, what does PKS really offer on top? Well, I'll just touch on a couple of things. First is there's no out-of-the-box HA for cluster components in Kubernetes, right? Like your master or your etcd nodes. When it comes to scaling, Kubernetes can obviously scale your pods inside Kubernetes, but what about being able to scale Kubernetes itself? In other words, can I add more virtual machines to Kubernetes and increase its capacity on the fly, right? And perhaps the most important thing is that PKS really gives you an enterprise-ready version of Kubernetes, right? So Kubernetes is, as you know, an open source project, very active, continuously evolving, and what PKS provides you is really a battle-tested, if you may, enterprise-ready version of Kubernetes. So I suggest you guys go through the PKS site. You can read up a lot on what PKS PKS has to offer, and you'd see a number of interesting things like the use of Bash for managing or giving you an experience across any cloud that is really consistent, or the use of NSXT that gives you isolation for your networks and better security. Okay, so let me get into the demo. I already have a PKS cluster that I launched on the Google Cloud. Let's start by inspecting the cluster. So PKS comes with a command line call PKS. Um, and it's a very easy way to essentially launch clusters. It's got pre-built plans like small, medium, large, that sort of thing. Anyway, I've already launched a PKS cluster um, called PKS cluster 0, and you can examine the status of that cluster. Um, and as you can see here, I mean, it's a small plan, and I'm running it in about 5 instances inside the Google Cloud. So the very next thing we want to do is we want to deploy our Composite Spark application, right? Essentially, my Composite application wants to deploy Zeppelin and Jupyter and all that, right? So before I show you that command, I think let me give you some context on Helm itself. So as I mentioned before, Helm is really a package manager that makes it super simple to deploy complex applications. You can upgrade them, and in a way you can avoid exposing developers to all the different Kubernetes concepts, which can be pretty complex and overwhelming. And in fact, you can even do things like roll back your entire application to a previous version, right? A core concept in Helm is a thing called as a chart. A chart is nothing but a YAML file that describes the desired state of essentially your complex composite application. So let's briefly take a look at the chart I'm using. Right? So this is the chart I'm using. It's just a YAML file, and as you can see in the chart, I'm essentially have a bunch of options to configure what I want for Zeppelin. Essentially, I'm configuring in the same thing what I want for Jupyter, and actually running like the Spark history server, right? The things of interest here is that, hey, I'm using essentially the GCS, the backend Google bucket to manage and retain all my historical events for my Spark applications that are started through my notebook environment. I am essentially managing and storing all my notebooks so that I can collaborate with my team inside essentially a persistent volume, so it can be preserved even if the pods running in Kubernetes are essentially bounced, right? I do the similar thing for Jupyter and likewise for other things. Anyway, so I have my YAML file, and the way I launch my application is simply using a single command called the Helm Install. I've actually already done this before, so it's going to give us an error. So essentially, this is pointing to that directory which has that YAML, my chart, essentially that describes my state of my application. So now let's look at the Kubernetes dashboard. And as you can see, I've actually already done this, but it has a number of these Kubernetes objects that it has created, right? Deployments and pods. So as you can see, I have pods running, and that is running my history server, a pod that's running Jupyter. I'm running pods for the Spark Shuffle service that really allows Spark to really exchange data across different executors and stages in Spark. I'm also running Zeppelin, so on and so forth. The other interesting thing here is that when I launched using my application, the Helm also launched a whole bunch of service objects inside of Kubernetes. And it's the services that gives us access to the different environments, like, for instance, my notebook environment from an external endpoint, right? So for instance, as you can see here, I can essentially go and get into my Zeppelin notebook environment, or I can get into my Jupyter environment with just one click. So if I'm in the Zeppelin environment, maybe I can, if I want to run a Spark application, it's pretty darn easy, right? I have in one place I have, and of course, remember, I mean, in Kubernetes, if any of these pods were to fail, Kubernetes will automatically, and PKS would automatically reinstantiate that pod, so you get essentially high availability characteristics automatically. So I can even, not only can I mean, of course, I can even look at let's look at a history server, for instance, which gives us access to all the historical events that have happened, right? So I can actually go back in time and analyze the state of things. And in fact, let me show you one more thing. I can in fact launch my launch even a Spark job from a desktop itself, right? So using Spark Submit, you can essentially start submitting jobs. And as you can see, when you submit a job, it gives you back the current status of what it's doing with the inside Kubernetes launching pods and whatnot. So what's going on here is that it should dynamically launch the pods that I need for my Spark job, right? So anyway, so in a nutshell, I guess what we've really seen is through Helm chart we have a composite Spark pipeline essentially running, and it's easy for us to manage, shut down, and even sort of version that entire application using Helm charts, right? So finally, what I want to quickly show you guys is, well, how exactly does Spark on Kubernetes work? It's a little bit different than how Spark works using the standalone, essentially, cluster manager. So when you submit a Spark job, what's happening here is that Spark, you essentially configure the Kubernetes master as your Spark master. And the Spark client essentially uses the Kubernetes master to schedule a pod for the Spark driver, right? And once the Spark driver is up and running, the Spark driver in turn talks to the master to schedule essentially one or more Spark executors, right? And once these executors are up, the Spark driver obviously directly talks to the executors and does not go through Kubernetes, so that's very efficient, right? So what does our overall architecture look like, right? What did we deploy? So this is sort of the graphic that depicts what we really did here, right? So we essentially took the Helm chart, we deployed it using Helm to the Kubernetes master. The Kubernetes master launched the Jupyter and the Zeppelin server. It also launched the service instances so they can get access to our notebook environment. And then it's the Jupyter or the Zeppelin server that when you launch essentially a Spark job in a notebook, results in dynamically a creation or launching of a Spark driver, which in turn launches our Spark executors. And all these Spark jobs are all writing their events into a GCS bucket. And it's a history server that also got launched through our Helm chart, gives us access to all those events that are getting continuously logged, irrespective of the application that's logging it. Okay. All right. So obviously, some of this must be overwhelming if you're not familiar with Kubernetes and Spark. But I do encourage you guys to give it a try. We have our GitHub repository. You can just search for SnappyData Inc. And the project name is called, the repository is called Spark on K8s. There's a README that provides step-by-step instructions. We encourage you to participate, contribute. And soon we will essentially provide another sort of screencast which goes through a bunch of SnappyData enhancements to what I just showed you, so that you can essentially manage state inside of Spark in a mutable, indexable manner, right? If you can, reach out. If you have any questions, absolutely reach out. You can send either an email to chomp@snappydata.io. You can go to pivotal.io/contact, or you can use any number of our channels, right, from Slack, Gitter, or you can just use the GitHub repository and log issues if you run into issues. So thank you very much.